So, hello. We'll talk about rounding, rounding decimals in particular. I suppose we'll probably relate it to rounding whole numbers so that you can understand it's pretty much the same thing, but just dealing with numbers that aren't whole. We'll talk about rounding to the nearest tenth, or the nearest hundredth, or possibly the nearest thousandth. Well, that's the red bit there, and the green bit says we'll round to talk about rounding to one, or two, or three, or more, I suppose, decimal places. And that second part, rounding to decimal places, is something that maybe some people get a bit confused about, thinking it's something other than what it really is. Hopefully you'll understand by the end of this that it's actually a different way of saying the same thing. But we'll come on to that. First of all, let's make sure we're clear about our place values. Let's just get rid of that. Here's a digit, a decimal, 0.35724. And I've just sort of sketched in the columns to remind ourselves what the column values are when we get into decimal fractions. And the first column after our nice big clear decimal point to the left of it, of course, we've got our units, our whole numbers. But to the right, our first column is worth tenths, so there's 3/10ths here. The 5 is worth 500ths, the 7 is worth 7,000ths, and we go 10,000ths and 100,000ths. Those are the column values. So if we talked about rounding to the nearest hundredth, we'd be rounding this column here. If we talked about rounding to the nearest thousandth, we'd be talking about the 7, wouldn't we? Rounding that 7 up or down. Let's do a few. I'm not going to use that number, it's a bit big for now. We'll start with something a little bit smaller. Let's talk about the number 35 to start off with. And let's talk about rounding that number. It's a whole number, I know. We'll start with a whole number. Let's talk about rounding that number to the nearest 10. If we talk about, no, I'm not going to say 35, actually, sorry. Number 36 and the number 31. We'll round those two numbers to the nearest 10. The numbers 31 and 36 both fall, do they not, between 30 and 40. They both fall between 30 and 40, don't they? What's halfway between 30 and 40? Can you tell me? Well done, it's 35, isn't it? Halfway between 30 and 40 is 35. So the question we have here is, in each case, is the number we're rounding nearer to 30 or is it nearer to 40? Well, we imagine putting 31 on a number line, and I think very clearly 31 is less than 35, right? So I fancy it to be somewhere like this, won't it? Whereas the number 36 is just a bit more than 35, isn't it? So it'll be somewhere like that. So by drawing on a number line, we can see that 31 is actually nearer to 30 than 40. So that would round, we call it rounding down, don't we? Because the number's getting smaller. The 3 remains a 3. We still have 3/10s, but the 1 rounds down to a 0. So 31 rounds down to become 30. Whereas 36 is nearer to 40, so it rounds up to that 40. And when we round a number up, the digit that we're rounding actually does get 1 bigger. So the 31 rounds down to 30, the 3 remains unchanged. 36 rounds up to 40, and the 3 gets 1 bigger. 3/10s become 4/10s, the 6 still becomes a 0. So that's a couple of whole numbers rounded. Let's maybe take those same whole numbers and turn them into decimals by putting a 0 point in front of each of them. 0.31, 0.36. And let's, instead of rounding to the nearest 10, let's round them to the nearest, what were these again? They were, let's check if we're not sure. Oh, that's right, the first column is tenths, isn't it? So let's round these numbers to the nearest tenth. And if we talk about rounding to the nearest tenth, then which 2/10ths are these numbers between? Well, they're between 0.3 and 0.4, aren't they? They both are between 0.3 and 0.4. And halfway between 0.3 and 0.4 is 0.35. Just like previously, halfway between 30 and 40 was 35. Halfway between 0.3 and 0.4 is 0.35. I could, if I wanted to, I suppose, just put that there to make it a little bit clearer, if you weren't sure. But actually, if we're grown up, we don't bother with those zeros, so we'll take them away for now. So there we go, halfway between 0.3 and 0.4 is 0.35. Where do our numbers fit on these number lines? Well, the same place as they did before, in fact. 0.31 is here, less than 0.35, and 0.36 is just a bit bigger than 0.35, isn't it? So it'll be just about there. So again, 0.31, the 3 would round down, so it stays a 3 and the 1 becomes a 0, so it'll be 0.30, we wouldn't put the 0, and 0.36 would round up, so the 3 becomes 1 bigger, it becomes 4 to make 0.40. Again, we wouldn't put the 0 because we're grown ups, so 0.36 rounds up to 0.4. So what is it that helps us decide if we just look at numbers? Can we decide, here's a better question, can we decide without drawing a number line? Do we have a way of telling whether to round a number up or down without drawing the number line? And the answer is yes, we do. what we do is we look at the digit that follows the digit that we're rounding. So in both these cases, we're rounding the tenths. We would look at the thousandths. In the earlier example with our tens, we actually looked at the units to help us decide whether to round up or down. And the rule is this. If you're rounding a digit, you look at the following digit, the ones I've arrowed in red here, and if that digit that follows the one you're rounding is 5 or more, you'll round up. If it's 4 or less, you'll round down. In the top example here, 1 is 4 or less, we rounded down, 31 rounded down to 30. In the second example, 6 being 5 or more, rounds up, so the 36 rounds up to 40. Exactly the same with the decimals. 0.31, the 1 is less than 5, so we round down. In the second example, the 6 is greater than 4, it's 5 or more, so we round up to make 0.4. Let's just do a couple of examples. 0.73. Well, if we round to the nearest tenth, there are the tenths. We look at the following digit. It's a 3, so it's 4 or less, which means we round down to 0.73 to the nearest tenth will be 0.7. 0.58. If we round it to the nearest tenth, there are our tenths, so we look at the following digits to decide whether to round up or down. 8 is 5 or more, so we're rounding our 5 up, so we become 0.6 to the nearest tenth. Of course, it works perfectly well, no matter how many decimal places there might happen to be, no matter how many digits there might happen to be here. You still look at the digit that follows the one you're rounding. So even with 4 decimal places in each of these numbers, we still get the same answers. It's just the digit that immediately follows the digit that we're rounding that decides whether to round up or whether to round down. That's rounded to the nearest tenth. Let's round a couple to the nearest hundredth. Let's take that same number, 0.7358, that we had on the previous page. Where are the hundredths here? Well, the first decimal place is the tenth, isn't it? So the second one is hundredths. There it is. If we want to know whether we're going to round up or down, we look at what? That's right, we look at the following digit. It's a 5. If we round up or down with a 5, that's right, we round up. So 0.7358 rounds up to 0.74. The 3 rounds up to become a 4, so we get 0.74. Here's another one, 0.3924. We'll round to the nearest hundredth again. Where are the hundredths? There they are, the second digit after the decimal point. So are we going to round it up or down? Well, we'll look at the following digit to the side. It's followed by a 2. 2 is less than 5, so we round down. So 0.392 becomes 0.39. It rounds down to 0.39 exactly. Okay, good. That's rounding to the nearest tenth, rounding to the nearest hundredth. Of course, I could rub this out and round this to the nearest thousandth if I wanted to, I suppose. Where are the thousandths? It goes tenths, hundredths. There are the thousandths. We look at the following digit. It's a 4, so we round down. So we get 0.392. That's that number rounded to the nearest thousandth. So we've rounded to the nearest tenth. We rounded to the nearest thousandth. Just be careful. You might get a question like this. If you're asked to round this to the nearest tenth, where are the tenths? They're just after the decimal point, aren't they? The first digit. Did it round up or down? Well, we look at the following digit to the side, and that's a 6, which means we round up. So 0.962 rounds up. And lots of you want to say it becomes 0.10, because 10 is 1 more than 9, right? But that's not quite the right answer, because in fact that's not 0.10 you've written, it's actually 0.1. So you've gone from having 9 tenths in your original number to having 1 tenth in your rounded number, and that doesn't make sense. If we're thinking of rounding this number up, we should be getting bigger, and we've actually got smaller. So let's rub that out, and let's just draw the number line again, just to reinforce our understanding. 0.962 is between 0.9, and if you add 1 tenth to 0.9, you get 10 tenths, don't you? 9 tenths plus 1 tenth is 10 tenths, and 10 tenths is 1 whole. Halfway between them is that, and 0.962 is just about there, isn't it? So it's going to round up, and when you round it up, it doesn't get into 1 tenth, it becomes 10 tenths. You could write it as 1.0, couldn't you? But in actual fact, a grown-up boy would just write 1. So 0.962 rounds up to 1. That's a problem you might come across before rounding whole numbers. When you're rounding 9s up, you have to make sure that you round them up correctly. Okay, now let's go back to these questions again to talk about let's go right back to the very first page, just to remind ourselves of a phrase that we talked about, rounding to a certain number of decimal places. Well, you've heard me mention them actually as we've been going through here. Decimal places are very simply the digits that follow the decimal point. And so this number, you may have heard me talk about it earlier, has 1, 2, 3, 4. It has 5 decimal places because there are 5 digits following the decimal point. And so if we talk about rounding to 1 decimal place, what we're talking about is rounding the first digit that comes after the decimal point. So in this case, it was these 3's here. So if you talk about rounding to 1 decimal place, this one here, we're talking really about rounding to the nearest tenth. It's exactly the same thing. It's a different way of saying the same thing. What's it like? I suppose it's like saying 3 times 7 is the same as the product of 3 and 7. I suppose it's like saying 7 minus 3 is the same as 7 subtract 3. Two different ways of saying exactly the same thing. In this case, if I'm looking to round to the nearest tenth, I can call it rounding to the nearest tenth, as I have done here, or I could call it rounding to 1 decimal place. Same thing here. I rounded these numbers to the nearest tenth. That's rounding to 1 decimal place. In these questions here, the top one, I've rounded that number to the nearest hundredth, haven't I? That's rounding to 2 decimal places, because the hundredths are the second decimal place after a decimal point. The lower number in black, I've rounded to 2 here, didn't I? And that's in the thousandths column. So I rounded that number to the nearest thousandth, and that's actually the 3rd decimal place. So I could write it as that, the 3dp, of the 3 decimal places. So rounding to a certain number of decimal places is like rounding to the nearest tenth or hundredth or thousandth. It's just a different way of saying it. So rounding to 1 decimal place is rounding to the nearest tenth. Rounding 2 decimal places, as I have done here, is like rounding to the nearest hundredth. And rounding to 3 decimal places, as I have done at the bottom here, is like rounding to the nearest thousand. Different phrase, meaning the same thing. I hope that helps you understand a bit more about rounding decimal fractions.